Welcome to the arithmetic zone, and today we're going to learn how to complete the square. So about this method, when you complete the square, what you do is you take a quadratic equation written in standard form, so ax squared plus bx plus c, and you want to convert it into vertex form. If you've never heard of vertex form, I have it on the bottom right here, where its perfect square is shown, and I wrote perfect in quotes because it technically isn't a perfect square. It might be a fraction inside, but the point is that we arrange it so that we take the square of a binomial, and when we write it this way, what h tells us is the x coordinate of the vertex, and what k tells us is the y coordinate of the vertex. And the vertex of a quadratic equation is either the minimum or maximum point of the function, and a is just a vertical stretch, and it can also tell you if it's up or down depending on the sign. So enough about that. Let's get into our first example. Relatively simple. We have x squared plus 6x plus 8. Now we could definitely just choose to factor this using AM method, but we're going to see how we can solve this by completing the square. So the first step you do when presented with the problem is to identify the b term. So that would be right here, plus 6, which is the coefficient in front of this x. Once you have this b term, what you want to do is follow this little formula, but we're not going to do anything with the function just yet, so we're going to write it off to the side. So what I'm going to write is the b term divided by 2 and then square it. So what our b term is 6. So 6 over 2 squared. So 6 over 2 is 3, and when you square 3 you get 9. So what you want to do with this 9 is you want to add and subtract it to this function, and doing that doesn't actually change anything with the function because we're adding the same number and then subtracting the same number, so it ends off how it was before. So if we do that, we write it like this, and I specifically wrote it in this fashion by putting the plus 9 next to the 6x, because from here is where you want to like group these terms. So what you want to do now is factor this using AM method while simplifying these last two terms. Let me just keep that minus right there. What you should notice is that when you try to factor this after completing the square, it's always going to be the same binomial squared. So if you remember, our what we did to get this was 6 over 2 squared, or 3 squared. I don't know why I wrote parentheses like that, but what the value is inside the parentheses is always going to be the b term over 2, so in this case 3. So we have x plus 3 squared, which is equivalent to x squared plus 6x plus 9. And then when we simplify negative 9 plus 8, that's just minus 1. Hence, this is the vertex form of x squared plus 6x plus 8. So we successfully converted it from standard form to vertex form by completing the square. Now what I want to do from here is, let's say we were trying to find the roots of this equation. So when finding roots, usually you would just set that equation equal to 0 and then solve for x. So our first step after setting it equal to 0 is move this coefficient, or not this coefficient, sorry, move this constant minus 1 to the other side. So now we have x plus 3 squared equals 1. And after that, you want to get rid of the square by square rooting both sides. So when we do that, we have x plus 3 is equal to not 1, even though the square root of 1 is 1, but also negative 1. We have to account for both the positive and negative values, because this is a quadratic equation and there could be two solutions. So after doing that, when you have the plus or minus value, you want to like branch it off, right, and account for both the positive and negative 1 separately. And then after that, you want to subtract 3 from both sides to get your two answers. So if we do that, we get x is equal to negative 2 and x is equal to negative 4. Those would be the roots of the equation. And of course, like I said before, you could have just easily found this by using the AM method. You didn't have to complete the square for this function, but for more complicated questions, it may be your best strategy. Such as example number 2, 2x squared minus 6x minus 8. First thing you might notice with this question is that this time there's a coefficient in front of the x squared. And when that happens, even if it's something like -1, we're going to have to address that. So the first thing you want to do, actually, before you move on, is to factor out these two left terms right here. You want to leave the constant alone. And you're going to see why later on. So we have 2 being multiplied to both x squared and -3x. That'd be equal to 2x squared minus 6x. When we set it up this way, we successfully make the x squared have a coefficient of 1. So we can now begin our completing the square process. Once again, we're going to identify the b term, which in this case it's -3. Now keep in mind it is being doubled by this 2, and we're going to factor that in later. So when we take our b term divided by 2 and then square it, the result is going to be positive 9/4. So what that means is we're going to add and subtract 9/4, and we're going to do it inside the parentheses. So what you should get is 2 being multiplied to x squared minus 3x plus 9/4 minus 9/4, and then minus 8 outside. So this is mathematically equivalent to these two functions right here. And from here, what you want to do is you want to move this -9/4 outside the parentheses, but this is being doubled. So what that means is that if you double -9/4, it's going to turn into -9/2. So moving it outside, we now have 2 times x squared minus 3x plus 9/4, and outside we have -9/2 minus 8. So from here on out, we want to factor this trinomial right here, and like I said before, the constant that's going to be in the parentheses squared is always going to be your b term over 2, which if you remember was -3/2. So we do that and we get 2 times x minus 3/2 squared minus 25/2. The 25/2 is the result of simplifying these two constants right here. So that's completing the square with that function. If we were finding the roots, once again, we're going to set the whole function equal to 0. Let's move that 25/2 to the other side by adding it. And now let's divide by 2 so we can work on this little squared binomial. So when we divide by 2, 25/2 divided by 2 is just 25/4. Now after that, you want to square root both sides. Square rooting 25/4 may be tricky, but think about it this way. What number squared equals 25? Well, that would be 5. And what number squared equals 4? Well, that'd be 2. Hence, the result is actually going to be plus or minus 5/2. So we do that. X minus 3/2 is equal to plus or minus 5/2. And once again, we have to account for both the positive and negative versions of that number. So let's branch it off and solve for x in both cases. So we add 3/2 on both sides, and we get that x is equal to 4 and x is equal to -1. Now, I know what you guys are thinking. Why couldn't I just divide by 2 in the very beginning? And well, if you were finding the roots, then you could have done that. But you can't just divide by 2 if you're not necessarily finding roots. If you're just taking the function and, just trying to simplify it, you can't just, divide every term by a number if it's not being equal to 0. If it's being equal to 0, then, we can multiply or divide by any number we want. Think about it this way. It's like saying y equals x and y equals 2x are the same. And, well, they're not. But if you're trying to solve for 0 equals x or 0 equals 2x, then they'd be the same, because then I could just divide by 2 on both sides and get that 0 is equal to x. So make sure you keep that in mind. and make sure you know what exactly you're trying to solve for. If you're trying to find roots, then yeah, by all means, you could have definitely divided by 2 in the very beginning and use AM method, or even complete the square from there. But if you're just trying to rewrite the function like this, then you're going to have to account for this too. Anyway, let's go on to the next example. X squared plus 4x plus 5. So usually I make my last example, I have a twist in there, but this looks pretty simple. So let's see what's up. Find the b term, which is 4. So 4 over 2 squared is going to be 2 squared, which goes back to 4. So we're going to add and subtract 4, and we get that. So x squared plus 4x plus 4 minus 4 plus 5. We want to factor this trinomial and then simplify the remaining portion. So again, the number that's in the parentheses is always going to be b over 2. So 4 over 2 is 2. So x plus 2 squared plus 1. And that's pretty much it to get it in vertex form. Now let's find the roots. So we set the whole function equal to 0. Okay. Now we want to move this constant to the other side. So we now have x plus 2 squared is equal to negative 1. And now we want a square root. And, well, that's a problem. Square root of negative 1. That is an imaginary number. It's a number that doesn't actually exist. And if you don't know what that is, I did make a video on it a long time ago. And I think it still holds up pretty well, so I do recommend checking it out if you haven't done so already. But anyway, square root of negative 1 is equal to imaginary number I. So let's change that up real quick. X plus 2 is equal to plus or minus I, because remember, we're taking the square root of it. So we add plus or minus I, and we're going to account for both the positive and negative I. So when we subtract by 2 on both sides, we get that our roots, or imaginary roots, are x equals negative 2 plus I and x equals negative 2 minus I. If you were to graph this equation in your calculator, you would find that x squared plus 4x plus 5 never actually touches the x-axis because these are imaginary roots. So that's the cool thing about vertex form. You could account for negative square roots. Same thing also happens with using the quadratic formula, but this demonstrates the weaknesses of other methods, like just the basic AM method, where you're really only able to use, constants as your factors. So vertex form can be very useful in certain situations, and it's also useful for the SAT because there's definitely going to be questions on there where you're going to need to know how to rewrite these functions into vertex form. Anyway, that's going to be it for this video, and I'll see you guys next time.